Hey guys, welcome to my shop here in sunny Worcester, Massachusetts. A little different than Grafton. Hopefully we can get a few things accomplished at home during this unique time that we're in. Today I wanted to walk through a couple of things that we've talked about in the past, kind of refresh your memory a little bit, and hopefully give you the basics that you need to try to get some of the work we'd typically do in class done at home. So you probably recognize a few pieces of equipment that I have here. I have a computer, kind of like the ones that we have in class. I'm running the same software, running Aspire on here. I also have Mach 3 that runs on here. And I have a CNC machine. My machine's a little bit bigger than the ones at school. The ones at school are a 24 by 36 inch. This is a 48 by 48 inch machine. It's actually by the same company that we have from school. Today what I wanted to talk to you about is manufacturing and kind of refresh your memory on how it works so that we can apply that to a project that you could do at home too. If we look at manufacturing, we think about the things that actually make it actually function. There are three main points. What we're trying to do is we're trying to take control of things. We need to actually be able to control what's happening. We need to try to be consistent or repeatable, that we can do things over and over and over again and end up with the exact same results. The way that we do that is by making sure that we have control. And our last thing that we have to do is be efficient at what we do. We're not wasting time. We're actually thinking through to make sure that the work that we do is of quality, but also done in a timely fashion so that we can generate wealth from that. Basically, we're trying to make money when we manufacture things. So what we're trying to do is trying to balance out what is the quality that somebody expects compared to what type of time we can spend on it and still be profitable. Okay, I want to show you a project that I've been working on. I've been making some doors. Yesterday I made a bunch of doors for my house. Okay, I have some cabinets in a laundry room that I hadn't made doors for yet, so I punched these out yesterday. A couple of things you'll notice is that I have different size cabinets too. You can see that these two, although they're similar, a little bit different in height, but a similar style. And we can even step up to a bigger one. And obviously this one's way bigger in size. But the same basic style of cabinet. Okay? What I had to do as I was making these is to try to consider, how can I control this? What do I do? What do I have control over? And how can I do that? How can I be consistent so that my doors are consistent? They're the same every single time that I do it. And how can I be efficient at doing that? The way that I did this was very similar to what we do in the shop every single day. I had to first consider the size and shape that I wanted. These are all rectangular doors. They're actually a 5-piece door. They're made up of a center panel, a couple of vertical pieces that we call stiles, and a couple of horizontal pieces that we call rails. And in order for me to figure this out, because there are multiple pieces, I had to do some math to try to figure out exactly how the pieces are going to go together. What's that going to look like? So I started with some pieces that look more like this, just a thin little piece of plywood here, and some 3/4 inch poplar boards. And what I have to do is try to think about, how are these things going to go together? How are they going to connect? What's going to hold them together? And how are the pieces going to interlock to make up that door? Obviously, we have to have something that holds it in or just slide by, and something that connects it to make sure that everything's going to function the way that we want it to do. If we take a look at just the edge of one of the doors that I did, you can kind of see how this works. You can see that this piece is notched into the other piece, okay? And when we look at it across the front, we can see that it's flush on the front here, but that it has that notch that's in there. That notch runs all the way down this board. And that's what allows the panel to fit in too. The panel sits into that same little groove that's in the board. And then these pins go in and lock the stiles and rails together on the top and bottom. And that's consistent on all of the doors that I did. Again, think of control. Control, what can I do to make that work? And I came up with this kind of a joint to make the connection, okay, my control. And if I set my machines up right every single time, I can get those to be nice and consistent. The overall size, how wide the pieces are, or how long the pieces are, actually isn't going to make a lot of a difference, okay? Same process, and that's where my consistency comes in. If I'm consistent, if I'm in control, then I can do projects efficiently too. So again, I made all of these 14 doors yesterday, did a few other things too, because I had to glue them all together. That takes a little bit of time. Do some sanding, that takes a little bit of time to try to be efficient in what I had to do. If you think about what it is that I needed to know, I need to know some math. I had to go through and figure out if all of those pieces are interconnecting, how much am I adding or subtracting to make sure all my pieces come out the right size. And when I set up my machinery, I have to do the same kind of thing. Think of the math, think of the geometry. Are things straight? Are they true? Are they parallel? Are they square? That's part of our control. The number one control system is our tape measure to make sure that everything that we have is coming out correct. We're using a system to make sure that those things are consistent. And I also use some geometry too. One of the most important geometries that I use is square. And I use a big square like this. Square just means that 90 degrees are perpendicular. And you can see that when I put my doors together, I'm going to make sure that they're square all the way around. Another control that I have, that I can make sure things are coming out correctly. If my machines are set up correctly, if they're set up square, my measurements are correct, then all of my doors are going to come out correct too. If I do that, take the time to make sure all of that works, that provides me efficiency. I can do it over and over and over again, repeatability, okay, and be efficient in the work that I do. What we want to try to do is build knowledge of that so that you can do something at home too, that you can take control over, whatever it happens to be. It doesn't have to be building doors like I did, it could be anything. You could be sewing a shirt together, you could be baking a cake. All of those things use the same process. We have to take control of what it is that we're doing. We have to try to be consistent, some sort of method of consistency. I'm using math and geometry to help me be consistent. If you were baking a cake, it would be very similar. I want to make sure that I'm using math, I'm measuring things to make sure that I maintain my consistency along the way. Take control of what I can control. How accurate am I? When I'm accurate measuring with a tape measure, okay, I try to get as accurate as the tape measure is. The tape measure I was using was accurate to within 1/16 of an inch, which provides me pretty reasonable accuracy for the type of project that I'm doing. If I'm baking a cake, I don't measure things in inches. Instead, I might use a cup of flour or sugar or a teaspoon or a tablespoon. All of those are other forms of measurement that allow us to control things and then allow us to be consistent. What we want to do in manufacturing is be able to do things over and over and over again and end up with the exact same result. So if you bake a cookie, can you make all of your cookies exactly the same? You probably heard Chip Ahoy cookies, 16 chips in every cookie. That's consistency. That's making sure that they have control of what they're doing. They're monitoring how that works, and they use that's just a tally, a count, to make sure that they're consistent. Every single one has the same thing. Okay? And that's what we're trying to do as we work through and try to figure out what it is that we're going to manufacture, what it is that we can take control of, how we can improve our consistency, and if we can do that and do it over and over and over again, then we can be efficient in our work. That's really what we're attempting to take a look at. Today I wanted to show you the next step of my project, and the next step that I'm going to do is to put in some hinges. This is a European style hinge that's going to hold my doors to the cabinets, and in order for the door to open and close, I have to get this to mount into the cabinet. The way that I'm going to do that is by drilling a hole. There's a hole that sits here, and I'm going to drill that hole into the back of all of the doors that I have. Okay, I need 2 of those holes on every single door, I need those to be extremely consistent, okay? Because the hinge is consistent too. We're gonna stop and think that everything that we do is reliant on the things we don't have control over. We talked about that being our limitations. One of my limitations is that I don't make the hinge. I have to buy the hinge, which means that I have to know a lot about it. I have to understand how it functions. I have to understand all the sizes that go along with it so that then I can apply it to the project that I'm doing and to make that controlled, make that consistent, and do it efficiently, okay? What I've done here is set up my CNC machine, just like our machine that we have at school. I started with a file that I created on Aspire, and probably difficult for you to see on the video, but what I did was just create a circle. In that circle, I told it how deep I needed the cut to be, and I'm cutting a pocket toolpath, okay? Once I have that design, I can head over to Mach 3, just like we do in school. I'm going to upload that file. So I uploaded a file to my computer, and you can see the circles here. What it's going to do now is to actually cut out that toolpath on my door. It's positioned on my CNC machine. My CNC machine is helping me take control. And one thing it's really good at is consistency. It does things over and over and over again exactly the same. One of the problems we're going to keep in mind is it only does what I tell it to do. So I'm still the brains of the outfit, even though I have a computer that always seems pretty smart to everyone, and I have a CNC machine that's really accurate and always seems smart to everyone. Don't forget, it's your brain that's controlling both of these things. Your brain is the one that designs it. Your brain is the one that tells it what to do. If we tell it everything to do correctly, it will do it all correctly. If we tell it something wrong, it's going to do it wrong. Okay? So we are the brains of the outfit. Once we make that and we send it over to our machine, same thing. Our machine is really consistent, but it only does what we tell it to do. So we have to make sure that every single thing that we tell it to do is perfectly accurate, exactly the way that we want it. The errors that come into play are typically human errors. Okay? That's me and you. So what we have to do is we have to pay attention to that. Understand that in the system, we're actually the weak link. Even though we're the brains of the system, we're the place that it falls down to. Okay? One of the things that I have to do is make sure my board's tightly mounted to the machine. My position is correct here. Okay? Using my X, Y, and Z coordinates. Make sure that the bit is correct. Make sure that my speeds are correct. If any of those things are incorrect, it's not locked down, it can go flying off. Wrong bit, it's going to make a wrong cut. Improper settings, as I set that, it's going to make a wrong cut too. What we're trying to do is make sure that we can get it again and again and again. I have 14 doors, which means I have to cut 28 holes for my hinges to fit in. Okay? So, let's turn this on. And we'll actually cut one of these so that you can see how that's going to do. Keep in mind, what we're trying to talk about today is control, consistency, efficiency. I have my file all loaded up. My bit looks to be in the right spot. My zeros are all correct. My X, Y, and Z coordinates are all correct. I'm going to raise my machine up so it's not touching. Double check, make sure I'm locked down. Everything looks good. Locked down. My file looks correct, okay? My machine looks correct, my bit looks correct, my boards look correct, my human error, hopefully they're all correct, okay? That doesn't mean that they won't make an error, but I'm pretty confident that what I've done to this point is looking pretty good. So I'll turn my machine on. Start with the spindle, turn the spindle on first. I let it get up to speed. And then we'll run that file. That was quick. seconds it took for the machine to do that. Nice and consistent, nice and efficient, nice and accurate. We'll move that out of the way. Unclamp it, we can take a look at what we ended up with. Get some of the dust out of there. I'll end up taking a piece of sandpaper and I'll sand that hole down a little bit. You can see it's a little rough around the edge there. That hole is supposed to be a 35 millimeter hole. That's the size of my hinge. We'll see if it fits. Look at that. Fits perfect. Hinge pops right in. Works perfectly. Lines right up. Pleased with that. Looks like what I've done. Taken control. I was nice and consistent. My machine is going to help me do this efficiently over and over again. 27 to go. Hey, we'll get to next time. We'll take a look at what it is that you're going to do for a project at home. Hope this made sense to you. Have any questions, feel free to email me. We'll get everything straightened out. Enjoy your time at home.